Hi everyone, in this video we're going to start the process of figuring out how to solve trig equations. So a lot of what we've done has been kind of building up to this. We want to be able to solve equations that involve trig functions. So we're going to try to start off with things that aren't too messy and work our way up. So this first one, we're told that sine of x is equal to 1/2 and we're supposed to solve. So this is not like identities. What we're doing here is picking out a specific output for sine, and we're trying to solve for the values of x that make this a true statement. So basically, I would want to read this as solve for all arc lengths x that make your y value on the unit circle equal to 1/2. So I would always draw a picture for these. There's some symmetry involved. There we go. So here's our y equals 1/2, and I think that a lot of people mess up the symmetry when they don't draw the picture. So I have, like I said, tried to start us off with a really nice one. So one thing you get here that makes it really nice is the fact that 1/2 is associated with one of our special values. So you hopefully could just tell me some of the answers by looking at this. But I want to walk through the process so that it'll work when we get to things that are a little messier as well. So the idea would be to first find one solution. So one arc length that lands at one of our points. We do have 2 points, but just to get us started, we're looking for one. When you're working on special values, you can probably just spot that this is going to be pi over 6. But in general, if you get stuck and you don't know that, you can use inverse trig functions to help you solve. So the algebraic step here would be to take the inverse sine of both sides to isolate x. So I want to take a second to point out something really important here. And this is one of the biggest things early on that you need to be thinking about. You should notice we've got a picture. I said I'm solving for arc lengths. I am expecting this to have infinitely many solutions. This equation, there should be infinitely many arc lengths. Not only do I have 2 different points, but for even one of those points, there are infinitely many arc lengths that I could take that would land me at this point. So yes, pi over 6 is one, but so is 13 pi over 6 or negative 11 pi over 6. There are infinitely many arc lengths that land at the point in quadrant 1 and infinitely many that land at the point in quadrant 2. So this has infinitely many solutions. Okay, so here's the part where you want to be careful. When you take the inverse sine and you say, okay, well then x is equal to the inverse sine of 1/2. This absolutely is a valid statement, but it doesn't tell the whole story. So one value of x will be the one that inverse sine gives you, but inverse sine will only give you one. So it gives one of the solutions. Okay, so we will make this step regularly, but number one thing for you to be clear of is the fact that inverse sine exclusively gives us the arc length between negative pi over 2 and pi over 2. And often when we're solving these things, we're looking for all possible arc lengths. So this is not going to be the end of the story for us. Okay, so if this is a special value, you should be able to find the answer without a calculator. When there are numbers involved that are not special values, that's when we'll start to use the calculator at this point. So it's okay to skip writing this down, but still the process is very first thing you should do is find one arc length that lands at one of your points. Okay, so this is great. We've got x equals pi over 6, but this is definitely not the entire solution. So I've actually given you a couple of steps to keep in mind. So find your one good solution, and then we're going to need to do 2 things. One of them is to find an arc length that lands at the opposite point, and the other one is going to be to use the period of our function to list all the rest of the arc lengths that land at each point. So for us, once again, I think it's a little easier with special values. But symmetry is going to be the trick we generally use. If this is pi over 6, then over here we've got pi over 6 from the negative side of the x-axis. So that's a pi minus pi over 6, or if you can just spot it, 5 pi over 6 is our other answer. So up here we'll say x equals pi over 6 or 5 pi over 6. And then we need to identify the period of the trig function that we're working with. So in this case, we're working with sine of x, which should have the standard period, 2 pi. So basically, what we want to say here is that pi over 6 is a solution, and anything that's one full lap around the circle from there is going to be another good solution. And the same is true for 5 pi over 6. So again, you want to make sure you tack on that k as an integer, because in this case, k is telling us how many periods we've tacked on to our original solution. And we're happy if that's 1 period or 2 periods or 3 periods or 4 periods, but we're not happy if it's, say, half of a period, which would give us a solution down here and down here. So we really do want that integer value right there. So what we've got is a starting point, and the period part tells us the spacing between our solutions. And then the k tells us the number of spaces that we've gone. So if k equals 3, then we've started at 5 pi over 6, and we have taken that increment between our solutions, that space between our solutions, and we've traveled that 3 times, which means we should still be at a solution. It's a different one, but it's still a solution. So that's going to be your process. Pick out one solution, one arc length that lands at each point, and then use the period to give all the rest of the solutions. All right, thanks for watching.